Hey, peace be with you, brother. Okay, any given angle, make a radius length unit 1 with your compass, and then reset point here, pencil tip here, make length 2, and finally length 3. Now this arc length is a third of this arc length, but the curvature is different. Curvature being the inverse of radius, and the different radius is then what I would want is to flatten this arc, and then I could fit it up there and find where are the points, the 2 points that will divide this arc of interest into thirds. Well, the chord, as a like triangle, is certainly 3 times the length. So I can set my compass here and then divide this. I call it the straight line limit, the rectilinear arc limit. If my compass along the midline was infinitely long and I drew an arc between here and here, it would be this flat line and it would be trisected. Trace back to the vertex. Trace those points back to the vertex, and then that infinitely small angle would be trisected. Well, let's look the other way. What if my compass point comes up this bisecting line and instead is here? Still the same endpoints. This is the curvilinear arc limit. And now you can call it the snow cone method. It's like I drew a snow cone. Setting the compass point here and pencil tip, I can then draw an intersect, and that's 60. Then that'll be 120, and then 180. And so using the same compass setting that I drew the semicircle with, I can trisect the semicircle. And now, consider this, that the trisecting point can't be any further to the left of here, and it can't be any further to the right of here, so I've boxed in the region that must contain the element that trisects the entire family of arcs that can be drawn between these endpoints. And then I'll explain really quickly the reasoning why you actually need to arc up to here. It's not just straight line connect. The consideration of the penultimate rectilinear arc. Let's say I could have an infinite setting on my compass and make this rectilinear arc limit. Well, what would be the element before that? It would have a tiny height and basically form a right triangle. This is the penultimate rectilinear arc and actually has 2 straight lines to it. And to trisect it, I must come straight up. To come straight up, I must depart orthogonally, which is the property of an arc constantly curving up. To find that, I simply extend the rectilinear arc limit and then I bisect between these 2 points. So that is, in other words, to just basically intersect circles. I draw a circle of some radius here from this point and a circle from here, and where the 2 points connect will be along a midline, it must be, and then where that midline intersects here is where I'll have to set the compass point, and then the pencil tip here will trace up and show the trisection of the family.